Well, hello and welcome to this webinar on designing for outdoor comfort in extreme environments and challenging terrain. My name is Dr. Nagman Khan. I'm from the marketing team here at Simscale, and I'm delighted to welcome you to this webinar where we'll be joined by our guest presenters from Link Arkitektur. This is an incredibly exciting topic that we've been looking forward to presenting for a long time. And what is that? So we're looking today at microclimate design in cold and windy environments with challenging terrain. Now, this is very important. The reason is that oftentimes when it comes to simulation, any kind of environmental simulation, CFD modeling, we tend to shy away from the challenging terrain topic, right? Mostly because the CAD issue and CAD handling is so difficult and sourcing the terrain data. But today we're going to confront that topic head on with a couple of experts from Link Arkitektur. And we'll be looking at how to use cloud native wind simulation tools, how to deal with complex terrain CAD, evaluating high winds in already windy climates, and taking a look at some external comfort parameters such as the UTCI for cold climates. Now, again, it's very important we understand this. Normally where UTCI is concerned, we tend to be more obsessed with hot climates, right? But I think it's really interesting to see the story from the other side today, right? UTCI for cold climates and where cold stress dominates. So let me quickly introduce Simscale to those of you who are new. Our job is to empower every engineer to innovate faster, okay, by making engineering simulation technically and economically accessible. Now, we have a cloud native simulation platform called Simscale that has zero software and hardware requirements, and it's robust, accurate, and fast, easy to learn and use. Now, we have a lot of architects and engineers using this. We can talk more about this later as well. There's a couple of key points here to the Simscale platform for microclimate analysis. Number one, a lot of the setup for traditional simulation workflows is automated for you with integrated climate data sets. Fast turnaround times using something called the lattice-Boltzmann method solver, which makes simulation order of magnitude faster than traditional workflows. And a lot of the post-processing and results analysis is automated. Now, we'll come back to seeing how Link Arkitektur used Simscale, but right now I'd like to hand over to our guest speakers, Matthias and Joel from Link Arkitektur. Please do pose questions using the questions pane in GoToWebinar. And after the presentation from Link Arkitektur, we'll come back and we'd love to take some of your questions and pose them to our experts. A copy of this video recording will be made available after the event. Thank you.
All right. Thank you very much for joining us. Our webinar is titled Outdoor Comfort in Extreme Environments and Challenging Terrain. I'm Mathias Sønderskov, and I'm the computational design lead here in Link Arkitektur, and I'm an architectural engineer working with daylight, wind comfort, computational design, facade design, sustainability, and workflow development. Here with me today is Joel Lopez, a computational design architect at Link. He's an urban designer with a focus on environmental analysis and workflows for outdoor comfort and CFD wind analysis. The agenda for today, we'll quickly introduce Link and I/O and our process when it comes to outdoor comfort. Then Joel will show our 2 case studies and also the materials we have developed to teach and learn CFD. Finally, I'll talk about possible future development tracks. Link Arkitektur is amongst the largest architectural groups in Scandinavia, with around 500 colleagues in 15 offices across the region, and healthcare being a prominent business area. Over the years, we have designed and constructed more than 2 million square meters of hospital facilities. And we continue to develop methods and digital tools to solve tomorrow's global challenges on a local level today. Our focus is how we can activate computational design to evolve the healing potential of architecture while significantly lowering CO2 emissions. We have been developing in 6 digital pillars, as you can see here, and we have today we'll talk about the outdoor comfort, which is residing under enabling sustainability and quality of life. In Link.io, we are a computational network within Link Arkitektur. We connect architects, computational designers, data specialists from different disciplines to a powerful, competent, and broad computational design community. We do direct consultancy on projects and tutoring our in-house influencer network with computational interested colleagues in all of our offices. We also maintain and facilitate the connection between the architecture and our more technical backend, our suite of simulation software and data software. If we take a look into our engine room, this is sort of our tech stack. We in IO are working a lot with Rhino Grasshopper, and then we have developed our own Link EP early phase, and we are connecting to a lot of external data services and also our suite of analysis software. Now I would like to introduce you to the process we have developed to work with outdoor comfort. This process comes from our experience in the field with a scientific approach on climate conscious urban design. And this is something still that's a little bit new for us here in Link Arkitektur. We have been working with outdoor comfort for around 2 years now. First step is take a look at the Scandinavian context. And it's about assessing local winds. It's about, in many cases, to shelter our location. And it's about setting up our cities in a way where we can avoid the cold stress. As Nachman pointed out, we have in a lot of other climates the need for shade and so on, whereas we in Northern Europe, we kind of embrace the early spring days where we can sit outside without too much clothing on. We have been waiting to get out the entire winter, and now we want to get out without the wind stress. When we look at wind simulations, there's sort of 3 steps if wind simulation is relevant. And the first is, are we first row against the wind? That's if in Danish context, for instance, in a lot of cases, the wind is from west. So when we're saying this, are we the first, let's say, barrier the wind will meet when it comes towards you from west? Also, are we breaking the scale? Doesn't have to be big, but if it's bigger than your neighbor, it can affect because we are building up in a layer of winds that are unprotected. And it means it can drag down winds of higher speeds down on the ground level. And also in general, if we are building tall or in tall context, we also have to pay attention. There's a lot of different patterns on how wind acts around the built environment. On the front of the buildings towards the wind side, there's always building up high pressure, and there's a negative pressure on the backside. That means that every time we are building a large volume, the wind needs to get around it to the other side. This this will cause a speed up around corners of the building, but it will also drag down wind from high altitudes down on the ground level. A good example on how we have handled that is here in AUH Forum, a hospital building in Aarhus, where we have a tower in the middle, but we're doing these plateaus to make sure that the downdraft that comes from the tower comes down on the roof of the building here, instead of down on the ground level. We zoom in here, we can also see that we've been working with awnings to protect the main entrances. Another thing we're using a lot when we're doing urban design is both working with closed building typologies and use vegetation to shelter more from the wind. When we're talking vegetation, we are not talking just one bush or one tree. I mean, we need high quantities before we can really shelter for the wind. And another thing one should also pay attention is that the vegetation is only sheltering in the summer half year, unless you have an evergreen type of vegetation. The second step when we're working with comfort is knowing our weather data. This includes everything from temperature to wind. And when we're looking at the weather data, we have everything spanning from, sunny days, overcast days. We have a typical year. We have a heat-stressed year. We have heat waves at the moment in the summers, and we also have a lot of changing climate in the Scandinavia. We have a lot of sources for our data. One of them is the Meteor Blue that comes bundled with our Simscale subscription. In most cases, this has been a really, really good source. But when we are working in Norway, I'll show a diagram later, things are changing so rapidly locally, you don't have to move many kilometers before everything's changed. So we also have other sources. For instance, in Norway, we have this Microclimate service. Joel also made a blog post about how we treat our wind data. You can click the link here or scan the QR code with your phone. Most of you guys who have been working with wind probably knows a windrose, but do you really know what it represents? Because one thing is, should we go for the most predominant? And what is the most predominant? Is it the one that is has most frequency direction, or is it the direction with the highest speed, or is it something else? Just zooming in on one direction, these colors actually represent a Weibull curve. This is a distribution curve. It comes from statistics, but it's also well used in wind simulations. This is not the actual one from this one over here, so don't get confused. But the Weibull curve basically states how often do I have different wind speeds. It can be for the entire year, or it can be for one wind direction. When we're looking into our comfort criteria, for instance, the Lawson or Lawson LTDC, it could be that you want, it typically says outdoor diving is good when you have less than 5% with 2 meters per second. It means that this threshold is not broken or exceeded for more than 5% of the year. What it inversely say is that we want 95% of the year to be below 2 meters per second. That's when we recommend an area to be good for outdoor dining. And when we look at the Weibull curve here, then it means that if you're looking at 2 meters per second, we should put a line here, and then we can count the frequencies up here. So in this case, it would be 10% of the time that we have below 2 meters per second. If we're creating shelter with our buildings, it means that we are pushing on the statistics, we are slowing down all the speeds. So the speed that before was 10 meters per second will jump to the left and is suddenly, 5 meters per second, depending on how much we slow it down. And that means that the entire density inside my threshold here has changed. So here we went by slowing it down from, let's say, 10% of the time to 18% of the time. We're not nearly anywhere near the 95% that I mentioned before. This is just a little statistical exercise. When we look at the Global Wind Atlas that's developed by our partners DTU, or not partners, our local university DTU here in Copenhagen, then you can see that the differences on the wind speeds around in Denmark, this is just the east part of Denmark, are not that big. We have less wind around the capital area, partly because of surrounded by forest and built environment. But if we go to Norway, you see that up here, the wind speeds are changing with 50% as soon as you move just a few kilometers. This is obviously due to the terrain up there, but it also means that I can't just do a wind simulation over here and use the data from Stavanger. That would be possible in Copenhagen to use the data from the airport and work in here. So setting up a climate strategy, Joel will show us a little bit about the UTCI on concrete projects later, but it's about protecting or creating wind. Or is there any other features like large buildings, forest, and so on we need to take in mind? And then also setting a goal, because do we want to lower wind speeds or make a higher UTCI in the entire area? Or is there certain areas like a cafe we want to prioritize? And we want to combine that with a strategy for also where's the sun, when. So maybe the cafe, we want the sun in the afternoon, and the baker, we want it in the morning. All of this has to be topped with a climate that's changing a lot. This is not predictions. This is just the measured average temperatures in Europe. And you can see that over the last 20 years, the summers have been increasing by a few degrees already. We are still quite cold here in the north, so it's not necessarily pushing us to change strategies, but we are facing a few really hot summers, and they will be more and more predominant. I'll now hand the word to Joel. Let me switch slides and give you the access, Joel. 1 second. You should be good now.
Perfect. Thank you very much, Matthias. And I will drive you a little bit through the next steps into the workflow that we have here on outdoor comfort. And step number 4 that we have approached is let's state and iterate. And this is about having this iterative process where we're first having a preparation of our model, setting up a simulation through the Simscale platform, running it and post-processing our results, and most likely analyzing these results to analyze again back to step number 2. So a little bit on the geometry preparation. When we're dealing with complex terrain, as the case in Norway, for example, which is one of our main markets, we have been able to introduce new tools for us to actually make this preparation of geometry easier. Here are some examples of Grasshopper scripts that we have used in our work. For example, a block to trees script, where we are able to just import whatever we have in a landscape plan, for example, and turn it into a geometry that is also assigning random heights within a range. Or this other example of a merge parser script, where we know the area of origin of interest needs to have a certain accuracy on mesh, but the outer parts of this region of interest don't need so much detail. And therefore, we automate and optimize computational resources. This is the same case for this script on region of interest, detailed mesh, where we're trying to mesh finer where it actually matters, closer to the region of interest of our project. The simulation setup that we work with in Simscale, where we can work both through the web platform, but also trigger a simulation with the API access, as we can see here. Just with the control of a Python script from the command line. Then the simulation runs, and after some time and some computational resources used, we are able to download our result in Rhino, for example, natively through Grasshopper and also dedicated Python scripts. And the post-processing results. Here, Simscale is still our main tool to do that, to be able to work with transient and animation results, for example. And we could also use external tools such as ParaView. So the fun part of our webinar starts, and we want to show you 2 of our best CFD case studies. And over the course of 2 years, we have worked in more than 25 projects, but we would like to show you these 2 case studies because they have challenged our workflow in terms of how we work with terrain and weather data, and also because they are good examples of this iterative process that we carry out in our projects in Link Arkitektur. The first project that we want to show you is the Minimating project in Bergen, Norway. And this is a new residential and commercial project between two very strong topographical peaks. So some of the challenges that we faced here, it was first about geometry modeling, but also about the setup of the wind tunnel that we needed to do for the simulation to run. And also the process of checking the weather data that we were using. So on top of using multiple gigabytes of topographical model, it's also about the setup that we put in the project. So here is an example of how our model was looking like. We have this in the center of our project, and this very prominent topographical peak, 350 meters tall, just next to our region of interest. So this was also an exercise of thinking, how much should we limit our region of interest and the terrain that we are including in our analysis because of the setup of the wind tunnel. And this is what I'm going to explain here, because in the background, the Simscale platform helps to automate this generation of a moderate size wind tunnel. But in this case, the extent of terrain that would be needed for this, it was to extend. This is because the wind tunnel size is always regarding the maximal height that we put into our model. And if this maximal height is too big, our wind tunnel can just grow bigger and bigger and spend more computational resources as well. So what we did here, it was to take a wind tunnel, a custom approach in this case, try to limit it at 2H relationship, this proportionality that we used here, and also try to make the best example for working with this complex terrain and also with this custom sizing wind tunnel. The next step that also helped us to rethink our workflow in this specific project, it was checking our wind data sources. As we mentioned, we're always checking first Media Blue within the Simscale platform, but then also our wind data sources that we specify, the Norwegian Climate Service Center, Global Wind Atlas, or the Danish Meteorological Agency. And what we found here, it was that in this specific case, the results between Media Blue and the other services were a little bit different. So our approach here was to prefer local and measured data. In this case, it was very important for us to have the most updated data, but also something that we can trust that is very close to our site, because with Norwegian topography, everything can change just at the other side of a fjord of a specific mountain. So it was very important for us to use this Norwegian Climate Service Center in this case. And within this importing of data, we also have a little workflow where we bring this wind statistics, and with a small template that we have on Excel to help us to do so, build up our own stat file and bring it into the Simscale platform, as we can see here. And therefore, we have our own custom wind data. This is the same process that we do when we're talking about a seasonal analysis, for instance, and this is the process that we have carried out in this project. So a little bit on the results here, we're generating a little bit of a report where the pedestrian wind comfort results that we get from the platform. We're also trying to give them an architectural design insight and how we can further improve for this iterative process that we embrace in Link architecture. So here you can see being north at the left that we have achieved a very good result on wind comfort in the iteration of this project, and we can see that more work in terms of wind comfort could be done in the higher levels of this project in the case of rooftop terraces and also going to the south. And it's Very important to say as well that within the design of this project, this is trying to work as a cluster of buildings that is trying to shelter itself from the predominant south and southwest winds. And then we also made the analogy, this development looks and works like little penguins that are trying to keep the worm in by being tightly close to each other. The second project that I would like to show you in this case is the BB Centret in Aarhus in Denmark. This project is an urban transformation where we try to do an add and reuse housing project on top of existing commercial buildings. So these towers that you can see are part of our proposal to densify this new center of a city. What is important about this project, it was the process that we followed on the design here. It was an iterative process where we first evaluated our first volumetry. The second iteration tried to go further into proposing comfort elements, and a third iteration was advancing this design proposal in a way. And also taking an insight into the UTCI data that we have for this location in Aarhus, we can already have an insight of the strategies that we would like to have regarding wind. So in this case, we can see in the lower graph that what we are experiencing between May and September is no thermal stress, but in the rest of the year, we're having cold stress. And then we're also trying to find out which is the main contributor to this situation. When we start working with very big data sets of wind and temperature and humidity, we also need to think about how to minimize the computational demand in our tools. So here you can see the example of the UTCI data that we have from an EPUW file, for example. So we would have hourly data for the whole year, 24 per 365. You can do the calculations, and if we have 10,000 probe points within our project, this translates to a very big amount of values that we have to manage. But if we take another approach into the representation of the data and thinking about taking parts of the year, let's say one day each 2 weeks, all around the year, we can actually work more efficiently with our computational resources and the calculations that need to come into addition here on the UTCI analysis. So here is the example of analyzing how big is wind speed in the whole UTCI equation, and here we can see that this is the Universal Thermal Comfort Index for Aarhus with a nominal wind speed. But if we take this exercise and multiply it by 1.3 or 0.5, here we can see how big can be the impact of wind speeds for achieving comfort in this environment. So this is done with the current temperatures of the EPW file, which is dated by 2013. But we also like to keep in mind what can happen in the future when, let's say, in a scenario of 4 degrees Celsius addition on air temperature happens. And this is also another insight on how we maybe start thinking about some days of heat stress in the Scandinavian context, but how the same approach of working with wind and trying to reduce it in the case of the winter months is our main approach here. So these are the results from the first iteration that we did on our volumetry in the project, and we started to pinpoint problematic spots where, for example, the predominant west wind that we can see here on the wind rows was affecting quite a lot the wind comfort, both on street level but also on the rooftop level, where is the urban life of this new project. This was our thought. And we were trying to optimize to have the best results on top as well. And after 2 iterations, we see that wind comfort levels on top of this existing buildings were able to improve quite a lot, and this was also because we were able to use our full set of tools, the ones that we talked before when we're thinking about our strategies, and also on design elements, talking about awnings or cantilever roofs. These are some of the elements that help us to achieve better results on wind comfort in this project. So it was a combination of vegetation, also on protective screens, cantilever roofs on specific blocks, and also a mix of windscreens and railings around the problematic points in the project. After we have achieved good levels of wind comfort, after our iterative process, we go to our UTCI workflow, which is right now a combination of Ladybug tools and the download of data with the Simscale API, and start thinking about the results that we can achieve after we have optimized for wind, which is our main strategy for this project. This workflow is a work in progress, and hopefully we can start including also more tools into this workflow. Something very important to keep in mind when working with UTCI is also having a scientific support for us, and this has been the case of using the London guidelines for thermal comfort. This has been one of the main guides for our work, and actually achieving good levels of scientific accuracy in the calculations that we're doing, and also practical know-how within the guidelines. So when we take the results of our iterative process, and we are well aware that high wind speeds are a big part of the UTCI equation, we can actually move forward with our workflow, take them into our Rhino platform. Here we can see the example of the prevailing direction on wind speed, and how we add up this to another calculation, which is the mean radiant temperature for the surrounding of our project. Also one of the Ladybug tools enabled calculation. And finally, we can come into a UTCI calculation here. We can see that we have tried to pinpoint the areas of our project to the minimum when we're talking about cold stress. And I think this was due to the iterative process that we followed before in order to try to achieve this less cold stress in as many areas as we can within the project. Here I would like to also talk about some of the materials that we have used to teach and spread the word on CFD within a company that it has more than 500 employees and even more than 10 persons within this computational network that Link.io is. We need to be very efficient on sharing knowledge and the results of our analysis. So we have tried to share knowledge with different tools and also results with our colleagues and clients. One of our tools has been to have a 2-hour course on CFD simulations and also how we work within Rhino and Grasshopper. So this has been a really good tool for our architects to have in our internal database where they can check a little bit about geometry preparation and the technical know-hows on CFD. When we need to go even deeper on wind simulation setup and usage of the Simscale platform, we prepared a white paper, which is only for CFD geeks, maybe like all of us that we are attending today, about the tricks and also the experience that we have had in these 2 years with working with outdoor comfort so far. We have also had the chance to develop CFD wind reports on some of our projects around Scandinavia. And here you can see the example of a Leibig Packing project in Stavanger, where it's going a little bit deeper into our designs and how we are achieving wind comfort with our architectural approach. Also, it has been really nice to use other external tools such as Speckle to share the models, for example, with the municipalities or clients and colleagues, and also the results that we achieve after running a simulation on Simscale. And then back to Matthias.
Thank you, Joel. Yeah, so a lot has happened in the last almost 2 years since we started looking into wind comfort and development and implementation of these tools. In our pipeline, sort of for further development, is looking more into the API. I know that Simscale has promoted a few other large companies out there doing their own Rhino plugins. We might look into something similar. Then we are looking into the expansion of the UTCI calculation.
Maybe I can just quickly finish saying that we have some workflows in mind, the expansion of the UTCI, as Matthias was talking about, and also taking this as a benchmark design parameter in our processes. For example, wind analysis is becoming more relevant right now in our main markets, for example, in Scandinavian, Norway, and Denmark. And what we would like to have is also to include it in further reports into our more general projects as well. And then we also have quite a few topics in mind: safety, pollution, natural ventilation, and so that we could start using the Simscale platform for. And I hope that we will have the opportunity to do so in the future.
Can you guys hear me now?
We
Yes.
can, Matthias, yes. Welcome back.
You can. Okay. My both of my screens are completely frozen. I don't know what happened. But yeah, I think that also kind of concludes. We would have shown a little link to a show off of our McNeil webinar, showing also some of the tools that we are developing and using. But feel free yourself, if you want to find it on Google, just Google the augmented architect McNeil, and you should be able to find it there. And other than that, also a thanks to Nachman for inviting us, and thanks to the entire Simscale team for being a good support and helping pushing us when we want to integrate new things on the platform. So thanks everyone also for listening in today. Do you have any finishing words, Nachman?
Yes, I do. Thank you so much, Matthias and Joel. I have a few questions, actually. If we can squeeze them in 2 minutes, maybe, that would be fantastic. Likewise, Matthias, Joel, thanks so much for the hard work and effort you've put in. It's very clear from the slides. You've done a lot of work here to share your insight and knowledge with everyone who's attending today. So we appreciate that, okay? And to your team, to your wider team as well, many thanks. We do have some questions coming in. I'm not sure we'll get through all of them, but let's jump in and see where we get to. So I was taking notes as well, Matthias and Joel, right? So a couple of questions around, you talked a bit about the London guidelines, for example, right? When it comes to wind comfort, outdoor thermal comfort. I'm curious, what's the regime like in Scandinavia? Are any guidelines being developed locally right now, or do you foresee this happening?
In Denmark, there's been there's no official guidelines, but there's been pointing towards the NEN standard. And to be honest, I have no clue if we will be going to adopt the London guidelines. But we in our team have been using the London guidelines to sort of aim for, mesh sizes and so on, the extent of context and so on. So we're trying to hit a level that is also being proposed by those guidelines.
Okay,
Yes.
okay, fantastic. Okay, my next question was, one of my favorite parts of your presentation earlier was when you talked about a climate strategy, right? Developing a climate strategy, know your weather data. And you showed this fantastic graph of weather data for the same location, but from, I think, 3 or 4 different sources. and the wind rows looked very different, right, for each one. So this was super interesting, and then there's some reasons why that may or may not happen. And you also mentioned, a changing climate. Is future climate years something you've looked at simulating using the forecast data from future weather projections? Is this something that's maybe on your further developments? That'd be interesting to see as well.
It is, but it's not something we've dug too much into. Again, from the graph that Joel showed, even if we add a few degrees more to the air temperature, we are still not seeing a lot of heat stress on, let's say, a typical year. But obviously, the frequency of non-typical years is increasing. So it's we don't have a full overview of, let's say, what's happening in 50 years now. And I think there's some consensus in science, but there's also a lot of there's many scenarios right now, and like we won't even hit the 1.5 degrees that everyone is aiming for in the Paris Agreement. So where are we going?
I think the data question is critical, right? You both touched on it. The quality of the data needs to be there for us to input into our modeling processes, right? Because the output will be as good as the input that goes in.
Yeah, but knowing the Scandinavians also, like when there's a heat wave here in Copenhagen, people, they swim in the canal. It's not like there's a drought. It's not like in Southern Europe, for instance. So I think for now, until we are hitting even higher temperatures, I think there's more benefits for making the spring and the autumn and maybe even the winter more comfortable than there is avoiding that 1, maybe 2 weeks of heat stress during the summer.
Exactly. By just quickly chipping here, I think how solid our climate strategy is here is the important part. We know that the climate will get more extreme, not only just hotter, because the winters will also get colder within the climate change, and the summers will get hotter. So the importance of our climate strategy is that we're trying to work for the majority of these days, trying to limit wind speeds, and I think this will also contribute to the comfort all year round, even when the climate is getting more extreme.
But I think also like it's about proposing city plans that have differences in them. So it's like last summer during a heat wave, I was in Firenze, which has more or less no public green parks, and you can run around and search for a bench and a tree for a long time. Whereas in Scandinavian context, we have a lot of places you can find wind, a lot of places you can find shadow in the city. So to be honest, I'm not too worried right now, but if you ask me in 5 years, I might say something different.
Nice. Okay, slightly more technical question. I thought the slide you showed with the tool stack was really great, right? You've got multiple tools. Obviously, this is a very complex problem. It needs a lot of types of data. It needs lots of different types of software and tools. Simscale is just one of many solutions that you guys use. One thing, perhaps our readers, attendees, and myself, we might not know that much about is, for example, Speckle. You mentioned the tool, right? What exactly do you guys use Speckle for exactly, and what is it used for? Because I think you said you use it to share models with municipalities, for example, but I think, Joel, I also heard you say results. Is that something you're showing results in as well, or more on the 3D side of things?
Here, so far we have experience doing both, sharing our models and also our results, because we're able to have our results on Rhino from the Simscale API and also send them to web platforms such as Speckle. So I think there's a lot of potential that we can actually see there, and how we work within even inside our same design process on making the results from Simscale more meaningful for the design process. This is something that we are always having in mind, and I think in the future it will just get better and better, this integration with Speckle. But I think it's a really tool with a lot of potential.
And that's fully on the cloud as well. It's accessed through a web browser. Am I right, Speckle?
Yes. Mm-hmm.
Yeah,
Yes.
we're seeing this. We're seeing this more and more. You know, we call it the advent of the all cloud tool stack, right? Where now you have lots of tools on the cloud. There's APIs in between. You know, APIs are used to communicate between the tools, and you have experts like yourself that have the skills to bring multiple tools together, right, in one place, basically in one team, or distributed. So that looks like very much is where the design ecosystem for architecture engineering is headed, right, and rightfully so. Construction is generally considered slow to adopt digital transformation strategies. This looks like a great example that you guys are using, and it's working for yourself, it's working for municipalities, it's working for your clients, your team members, your skills. So thank you so much. Yeah, go on, Matthias. Yep.
No, it's just another thing we like a lot about the Speckle is that it works a little bit like Git when it comes to code or text. It works like that for geometry. So you can create branches. So an architect can create a branch with a proposal, send it to Joel, he can do a simulation and he can push the results into that branch. And then you can flip through different branches, like design proposals, and you can comment and see differences. So it's a really good collaboration platform for everything that needs, more than just commenting on PDFs, basically.
Yeah, fantastic. I think we should wrap up there. We're a bit over time. It's just reflects, I think, how interesting the topic is and your presentation. And thank you for sharing your journey over the last 2 years as well. It's super interesting, right? And we'd love to have you back in a few months' time, maybe to do another follow-up webinar. I think everyone will be really interested in see in how you get on. So thank you, Matthias. Thank you, Joel, on behalf of Simscale and all the attendees.
Thank you.
Thank you.
Thank you. And I'll wrap up to the attendees. Thank you for joining. We will post-process this video and it will be made available on demand. Please feel free to pose any final questions via GoToWebinar, and we will try and answer as many as possible in a follow-up email when we send around the video recording. Thank you so much for joining. Goodbye.